So in example 6, we're putting it all together now. It says use the graph of f of x equals x squared to obtain the graph of g of x equals negative 1/2 x plus 1 squared minus 2. So we got a lot going on, and we're going to look at it piece by piece here. So first thing I notice is a negative. Remember, negatives are on their own on these things. So what does that negative in front do? Yeah, we know it's going to be a reflection. And because it's out in the very front, it's going to be across the x-axis. Well, that 1/2, what does the 1/2 do? Is it horizontal or vertical? It's not in parentheses with the x, so it's vertical. It's at the beginning being multiplied, so it's going to be a stretch or a compression. So which one is it if it's a 1/2? What happens when you multiply by 1/2? Does something get bigger or smaller? Smaller. This is with y. It's outside of the x. So it does what it's supposed to, so it's going to compress. So it's a vertical compression by the actual number. So 1/2. Then I'm going across. The next thing I have is that plus 1 inside. It's inside, so I know it's going to be horizontal. It's being added, so that's a shift. It's a plus 1, so is it going to go left or right? Well, remember, positive 1's over on the right, but with x we do the opposite, so we're going to go left 1. And then finally, we have that minus 2. It's not with the x, so it's vertical. It's being added or subtracted, so it's a shift. Which way does it go if it's a minus? Remember, now, not inside with the x does what it's supposed to. So minus means we're going to go down 2. You don't change things unless it's inside with x. Then it does the opposite. All right, so now we've got all the things we expect to see. Let's get our parent table. Well, even if they didn't tell me, guys, the only things that aren't a transformation is the x and then the squared. So x squared is my parent table. And now we're going to work on our transformation table. I'm going to start with just my x's. Is there anything inside with x? Yeah, it says x plus 1, but we know with x we do the opposite, so we're not going to plus 1, we're going to minus 1. So take all your x's over here and we're going to subtract 1 from them. So negative 2 minus 1. Negative 1 minus 1, 0 minus 1, 1 minus 1, and 2 minus 1. Good. Now, so that means everything else is going to affect my y's because they're not inside. So for my y's, we have this negative 1/2 times, and we have minus 2. Which one do we do first? Do we multiply or subtract first? Does y do the opposite or does y do what it's supposed to? Does what it's supposed to. So what are we supposed to do first? Do we normally multiply or subtract?
Subtract.
We normally multiply first according to PEMDAS, right? Multiply, divide, add, subtract.
Oh yeah, I'm just saying
So we're going to do y times that negative 1/2, and then we're going to subtract 2. So I'm actually going to write those down. So this is going to be times negative 1/2, and then subtract 2. So what is 4 times negative 1/2?
Negative 2.
Minus 2?
0.
Negative 4.
Oh, wait, what? I think you said...
You went the wrong way.
Oh.
You added 2.
Oh, yeah, my bad.
All right, so 1 times negative 1/2 is negative 1/2, minus 2, negative 2.5, good. 0 times negative 1/2, good, is 0, minus 2 is 1 times negative 1/2. Wait a minute, I did that one right there, didn't I? And so we get the same answer, so negative 2.5. And then when I do the 4, well, that's the same one I did at the top, so I get negative 4. So nice thing about the absolute value and the quadratics, if you haven't noticed yet, they have symmetry. So the top one and the bottom one should have the same y values. The second one down, the second one up should have the same y values. And the middle one's on its own. Alright, so let's graph these functions and let's see if what we thought was going to happen actually did happen. So I'm going to graph the parent function.
Oh, progress report. I forgot that. Oh, turn that. Did everybody forget about that? Did everybody turn their sign report?
And then I'm going to graph my transformed function.
I have the sign.
And then check it. So check it, guys. I'm going to go through my little list of stuff we said over here. We said it was going to reflect across the x-axis. Did it? Yes, it's upside down, isn't it? We said it's going to vertically compress by 1/2. Now that's kind of hard to see, but think about it. If you vertically compress something, so take that balloon and squish it down from the top and bottom, it's going to get wider. Does it appear to have gotten wider? Yes, a little bit. Look at these points. Do you see how close they are? And right there, how the bottom one seems like it's wider than the top one? So it did get wider. All right, did it go to the left one? When you're looking at left and right, look at that vertex. Look at this point right here and compare it to the point down here. Did it go to the right one? I'm sorry, left one, like we said? And did it go down too? Yes. So it did what we thought it was going to do. So there is our transformation.